Okay, so yesterday we talked a little bit about acids and bases, and specifically we talked about how to calculate pH, which we know is the negative log of the proton concentration. We also discussed that if you have a strong acid, it ionizes completely. As long as you have a monoprotic strong acid, and that's all I'll give you for these calculations, the concentration of acid is equal to the concentration of proton. You take the negative log of it to get the pH. If you have a strong base, you'll first calculate the POH, which is the negative log of the hydroxide ion concentration. Strong bases ionize completely. If you have a group 1 base, for every 1 mole of group 1 base, you have 1 mole of hydroxide ion. You can then calculate the POH by doing negative log of hydroxide ion. And what's the relationship between pH and POH? What do they equal when you add them together? 14. So if you know the pH, you can get the POH, or if you know the POH, you can get the pH. And as we said, for acids, you'll go directly into this formula. For bases, you'll start here, and then you can simply calculate the pH by doing 14 minus the POH. There's also a difference in regard to sig figs with pH and POH, and so that's something we'll review today and something that's on the video from earlier today. Okay, so yesterday we went through the remainder of these questions, and again, these were a little bit trickier. This won't be on the video that's posted. We did the calcium hydroxide concentration trying to determine pH, whether the solution's acidic or basic, and then we also finished up with this one. So feel comfortable with those as well. Remember, there are 3 strong bases from group 2 hydroxides, calcium, barium, and strontium hydroxides. So you want to be careful with those, because for every 1 mole of strontium hydroxide, you get 2 moles of hydroxide ions. So there's a slight trick there. And we can do more of those at the end if you feel like you need more practice. What we want to switch gears with here is we want to be able to calculate the pH of a solution when you're told the mass of acid that you dissolve in water. So this concept links back to what we talked about with solutions. So there's a couple things here we would want to review as well. And your semester exam is fast approaching. It's going to be on June the 1st. So you want to start to go through your notes and review some of the earlier concepts. One thing we talked about in regard to our chapter on solutions is there is a number of different ways to express concentration. The unit that we most often use for concentration is molarity, capital M for molarity, which is moles of solute over the total volume of solution in liters. And this is going to come into play right here, because we know that concentration is expressed as molarity. So if we can first calculate the concentration of an acid or a base, we can then determine the pH of the solution. So this is going to be similar to what we finished up with yesterday, but we're not going to be given the concentration. We're going to have to calculate it. So that's what we're going to look at here. And in number 6, we're going to walk through this type of problem together. and then we'll do 7 together as well, and I'll give you a chance to do some additional problems for practice. In number 6, the mass of nitric acid, and again, we will learn how to name acids probably on Monday, is 0.371 grams. And we dissolve it in a final volume, so the total volume of solution, SOLN for solution, is 751 mils. It would be wise to get that to liters right away. We've done this numerous times. Move the decimal 3 places to the left to get liters. You do know that 1 liter is 1,000 mils. That's a conversion that you're very familiar with at this point. The question says, calculate the pH of the solution. Is the solution acidic or basic, and explain. So this is similar to the previous problems with one additional step. And that one additional step is we first need to determine the concentration of the acid. We know that concentration is usually expressed as molarity, and that's moles of solute over the total volume of solution in liters. So they give us grams of acid and how do we get that to moles? Periodic table. We know from way back in the second 9 weeks that 1 mole of anything is equal to its mass in grams. And if you don't have a periodic table, they're on my desk, and if you need a calculator, please let me know. So we've got 1 hydrogen, we've got 1 nitrogen, we've got 3 oxygen, and that's 63.0119 grams. And that's 5.89 times 10 to the negative 3rd moles. Now molarity is moles of solute over the total volume of solution. So we have moles, we need to get molarity. How do we get molarity? Plug it into what? So we have the moles and we're going to divide by the total volume, which is what? Okay, so we've got 5.83 EE negative 3 divided by 0.751. And so the concentration then of this strong acid is 7.84 times 10 to the negative 3 molar. So again, this is similar to yesterday, but we're doing an extra step here in that we are first calculating the concentration of the acid. Nitric acid is a strong acid. Strong acids ionize completely, just like you saw in the video, and this is equal to the concentration of proton, or you might see it written as hydronium ion. For all intensive purposes, they are the same. Once you have the concentration of proton, how do you get the pH? Right, just like we did with the do now. So the pH is equal to negative log of the proton concentration is negative log of 7.84 times 10 to the negative 3 molar. And I do want to make one point. Some of you will be taking AP next year, and one of the things I had told you earlier is if you have 1 times 10 to the negative 3 without a calculator, you know the pH is 3. If you have a number slightly greater than 1, or greater than 1 period, just not less than 1. If you have a number greater than 1, the pH will be 1 less than the absolute value of the exponent, so it'll be 2 point something. And that's a good skill to know, because in certain courses, on certain SAT-2 subject tests, you don't get a calculator, so you do want to be familiar with math in your head. It's a very good tool to have. I know you've used calculators for a long time now, but it really is important, especially with SAT switching to more and more calculator list type parts, that you're comfortable with the math. So we have negative log of 7.84 EE negative 3. And again, you've got 3 sig figs here. Let's watch the math in terms of not only calculating it properly, but also expressing it in the correct number of sig figs. Sig figs for pH start after the decimal point. So you need 3 digits after the decimal point is 2.106. Questions? So you first need to calculate the concentration by converting mass to moles, dividing by the total volume, and then the pH is equal to the negative log of. Do you want to try, oopsie. Do you want to try the next one on your own?
Do you have to say whether it's a solution?
Did it ask?
Yeah.
Okay, so let's do that. It says, is the solution acidic or basic? Explain your choice. What would this solution be? The solution is acidic. How come? Because the pH is less than 7. And why don't you give number 7 a try? I will do it as well, and we can compare answers. I'm going to put 7 on the screen so you can see it. Okay. I'll show the answer. Yes, yes, you may have gotten 1.753. It depended on how you kept it, where you plugged it in, etc. Something close? Yes, yes? Okay. Now, what would happen if I gave you the mass of a base? What would be different here?
Calculating pH.
Would you go right into pH if I gave you a base? No, you would do the pOH first, and I've got a problem like that in a few minutes to really mix it up and make sure that you can do everything. Okay, this is a strong acid. You'll get its concentration. Because it's a strong acid, it ionizes completely, and these two concentrations are equal. And again, this has to be a monoprotic acid, one ionizable proton. If it were sulfuric acid, it works a little bit differently. I'm not going to give you that one. That's too advanced. Once you get the proton concentration, you can get the pH by doing the negative log of it. Okay. The other thing we want to be able to do is we know how to calculate the pH from the proton concentration, the pOH from the hydroxide ion concentration. Now we want to be able to go in the reverse direction. That is to say, if you know the pH of a solution, can you calculate the proton concentration? And you could extend that on. You could calculate the concentration of the acid, and you also could calculate the mass of the acid if you knew the volume. So there's a lot of ways to swing that. We'll start easy and get more complicated. Similarly, if you know the pH, you can calculate the pOH, the hydroxide ion concentration, the concentration of the strong base, and then the mass of the base. And this would be the acid. So there's lots of different ways that you can road map this. We'll start very simple. We'll go from pH to proton concentration, or pOH to hydroxide ion concentration, and then we'll try and really mix it up well so it reviews a lot of key concepts from solutions. Okay, so the formulas are given for these simple calculations. When you want to calculate the proton concentration, you can do so by 10 to the negative pH. When you want to calculate the hydroxide ion concentration, you can do 10 to the negative pOH. And on your calculator, that's going to be the second of the log button. It'll say 10 to the power. It's very easy to enter. I know you have different calculators, so we'll work through the different ones so you're comfortable with it. If you multiply these two concentrations, the product is equal to 1.0 times 10 to the negative 14. That's the kW for water. We're not going to use this year, just something we're going to mention. We're going to focus on what's highlighted in green. Two examples written out, and then we'll go through a whole bunch together. It says a solution has a pH of 3.45. Calculate the proton concentration. Proton concentration is 10 to the negative pH. 10 to the negative 3.45. 266 for pH here is 3.5 times 10 to the negative 4. Take a minute to try it in your calculator. It should be second log of negative 3.45. And you get 3.526 times 10 to the negative 4th molar. So make sure you're calculating that correctly. If you have the very simple TI-30, you're going to put 3.45 in, negative, then second log. Make sure you're getting the correct answer. You don't want to make a calculator error. If you have pretty much anything except that one, you're just going to put second log negative 3.45 and your answer should pop. Yes? Okay. On number 2, if you're given the POH and you want to calculate the proton concentration, we're going to focus on the easy way. I probably should flip these columns around. The pH is 12.755. How did I get that? 14 minus the POH. And then it's exactly what we did previously. Take a minute to plug it in. 3 sig figs in your answer. And remember, the unit for concentration is capital M for molarity. Make sure you're getting it. No calculation errors. Very, very easy quiz. Yes? Let's do number 3 and 4 together, and then I'll let you try 5. On number 3, it says the solution has a pH of 3.54. So the pH is 3.54, and we want to calculate the proton concentration. That's 10 to the negative pH is 10 to the negative 3.54. Unit for concentration is molarity, capital N, M. Second log of negative 3.54. 2 sig figs is 2.9 times 10 to the negative 4 molar. And that would also be the concentration for the strong acid. Questions on 3? Tell me how to do 4.
10 to the negative POH.
You could do it that way. There might be an easier way to do it.
Subtract my pH first.
Yeah, I would get pH first, but you can do it your way. It just involves the KW. So here you want to get the pH first. So we'd have 14 minus that is 8.53. And then we're asked to calculate proton concentration, which is equal to what formula? 10 to the negative pH. And when you put that in your calculator, what do you get? Yes, 3.0 times 10 to the negative 9 molar. You have the little calculator, right? Ready? You're going to put in 8.53, the plus minus button, second log. Yours is everything backward.
But then, like, I did it the same way the one that I got right, and now it's like 0.
No, because now hit second 5 and put it in scientific notation.
Yeah, now.
Yeah. Okay? Try number 5. I'll put 5 on the screen. right at the top of the screen. Try 5. And on 5, I got this. 4.0 times 10 to the negative 13 molar, okay? All right, we have one more little piece we want to do. We want to link these concepts together. Basically, what we did, where we got the concentration from the mass and the volume, and then we're able to determine the pH, we're going to run that in reverse now. You're going to be given the pH and the volume, and you'll be asked to find the mass. So I'll walk you through a few of those, and then what you'll really need to do is some practice in here. The do now question I'm going to leave for the end. That's a review of what we did previously. I'm going to do 6 and 7 with you now, and then when we finish these two together, I'll ask you to do 8 and the do now. And if you can do them, then you understood what we did today. I will tell you that after 8 is as far as the quiz goes. I don't have your quiz slated until next Friday because of the way the schedule rolled out. I think that's for the best because there's a lot of different little tests coming up next week, and I don't want to schedule a lot of makeups, and I just want to make sure that everybody's on the same page with what we've learned. So let's take a look at number 6. We'll highlight what's relevant here and work through it. There's nothing new here. It's just a matter of putting some different concepts together and doing it in the correct sequential order. It says, what mass of nitric acid, so that's what we will be solving for, must be dissolved in a final volume of 756 mL, that's given, and we want to generate a solution with a pH of 1.987, which is acidic. pH less than 7 indicates an acidic solution. So from the information that's given and what we want to know, we'll be able to solve this particular problem. We want to know the mass of nitric acid. So that's the mass in grams. The total volume of the solution is 756 mils, and you will need that in liters because we know molarity is moles per liter. So it's probably a good idea to address that right away. The pH of the solution is 1.987. The way we roadmap this is from the pH we can get what? Concentration.
Of H and of 3.
We can get the concentration of proton, which is the concentration of nitric acid because it's strong. So the first thing we're going to do is calculate the proton concentration. We know that that's 10 to the negative pH. And 10 to the power is second. I don't know. I learned it as antilog. I don't think you use that terminology anymore. It's probably old people terminology. I'll have to ask Mr. Marr. That didn't come out right. Not that he's old. I just figured he would know when the terminology changed. I think he's younger than I. Maybe. All right. 3 sig figs here. And as Mariana said, that is the concentration of the acid because it's a strong acid. Yes.
Why do you not put that in scientific?
Yeah.
You can. You want to? Do you like it better? Is that better? Okay. I like it better. I thought you guys would like it the other way better. Okay. Now, we want to get the mass, but we can't get mass directly. So what do you think we get first before mass? Moles. We know that molarity is moles per liter, correct? We did that at the beginning. We know that molarity is moles per liter. So if I want to calculate moles, how do I do that? Multiply by molarity by volume. All right. So the moles of nitric acid then is equal to the molarity times the volume in liters. So that's 1.03 times 10 to the negative 2 molar, which is moles per liter, times the volume in liters. Liters will cancel and you'll be left with moles. And then finally, going back to what we learned in chapter 7, in the second 9 weeks, 1 mole of anything is equal to its mass in grams. And I didn't put that in scientific notation. That you want it that way? I think some of you just have your calculators programmed as such, so it's easier. Either way it works. Okay, and let's just review what we did here. To get proton concentration, we did 10 to the negative pH. That gives us not only proton concentration, but because nitric acid is strong, these two concentrations are the same. Once we got the concentration of nitric acid, we could get the moles of the nitric acid by multiplying the concentration by the volume in liters. Once we did that, we got moles and we converted to mass in grams using the periodic table. Number 7 is similar, except we've got a base, so there'll be one extra step. We'll work through this one together as well. 6 is good?
So first you have to find the pH and then you do the mole over volume.
You walk me through the next one.
Okay.
All right? Number 7 says, what mass, I'm just writing down, given an unknown, of sodium hydroxide must be dissolved in a final volume, and I'm going to put this in liters right away so I don't do anything silly. And the pH of this solution is 11.087. Now there's just one thing extra to consider here. Is sodium hydroxide an acid or a base? A base. So do we want to work with pH or POH? POH. Hannah, how do we get POH from pH?
Subtract it from 14.
Okay. No, that's not 3, silly. 2. That's bad math. Yuck. Okay, 14 minus this. Now with the POH, what are we going to get next? Hydroxide ion concentration. You said you want scientific notation? And this is a strong base, so what is this concentration also equal to?
You asked like the next step.
Sort of. On the other problem, we said the proton concentration and the acid concentration were equal because nitric acid was a strong acid. So the hydroxide ion concentration is equal to what? The strong base.
Oh, okay.
So this is going to be equal to the concentration of the strong base. Now I'm asking for the next step.
That's when you do the mole over the V.
Okay, so we've got moles over volume is equal to molarity. We want to solve for moles. So moles of sodium hydroxide would be equal to what? The molarity times the volume in liters. Just like before, 1.22 times 10 to the negative third molar times the volume, and this just takes practice. Once you practice, you'll be good. Use the framework we established here, and if you do enough practice problems, you'll be highly successful. If you're struggling on assessments, you're not doing enough practice problems. Now that's moles, that's not what they asked for. What are we solving for? The mass. So we're going to convert moles we know that 1 mole of anything is equal to its mass in grams. Sodium hydroxide is about 40. And we'll be using sodium hydroxide in our titration lab, which is really fun. You'll love it. I'm going to put a little hour here because it's going to get too squishy. Do you want scientific notation for the answer? You like that better? All right. Yeah, but I ran out of room. 2.66 times 10 to the negative 2 grams. just a little quantity. We'll get rid of that. Right there. Okay, so the only difference in this problem is recognizing that it's a base and to use POH. Your goals today are to know how to calculate proton and hydroxide ion concentration, that's the second log feature, and then how to incorporate or integrate what you know about molarity, linking pH to mass and being able to work it both ways. In the next 14 minutes or so, you want to make sure you can do number 8, and you want to go back and do the do now. On your classwork, which you got the other day, you can finish the table on the front side, and you can work through number 21. Questions? We're good?